Hi AFM students, this is Ms. Van Vickel, and this is part 2 in your Not Spring Break Day series for March 23rd. And I'm going to take a look at the trig ratios that we just saw in part 1, but we're going to do it from kind of a special point of view. You'll notice I've graphed a point at 3, 4, and that point, I've made a circle go through that point as well, with the center of the circle being at the origin and this point 3, 4 being on our circle. So I'm going to make a ray through that point that originates at 0, 0 and goes through my point on my circle. And I'm going to make a ray right here along the x-axis. And I'm going to notice that this angle here, formed by these two rays, is an angle that I'm interested in finding my 6 trig ratios: sine, cosine, tangent, and we'll also find cosecant, secant, and cotangent. So let's take a look at how we're going to do that. The first thing we need to do is we need to make sure we have a right triangle. And if I draw a perpendicular line right here, I have a nice little right triangle with theta here, my opposite side having a value of 4. And keep in mind that's my y value, 1, 2, 3, 4. Right there, my y value. And I have an adjacent side with a measure of 3 units. That's my x value. Let me make sure that we all are on the same page with that. 1, 2, 3 is my x value, and 1, 2, 3, 4 is my y value. So there's my point at 3, 4. And I'm interested in finding, again, the 6 trig ratios for this angle theta. So I'm going to consider opposite over hypotenuse. And if we remember our Pythagorean triples, if I have legs of 3 and 4, my hypotenuse has to be 5. It's a 3, 4, 5 triangle. So my sine becomes 4 over 5. But I want you to observe something very special. Not only is this opposite over hypotenuse, but it also happens to be my y value over the radius of my circle. I'm going to do the same thing with cosine. Cosine is adjacent over hypotenuse, which would be 3 over 5. But that can also be thought of as x over r, my x value, over the radius of my circle. And tangent is going to be opposite over adjacent, which can be thought of as y over x. So now that I've superimposed my triangle on a coordinate plane, I have a nice little way of finding these trig ratios using my xy values and the concept of a radius of a circle. Let's go ahead and do secant, cosecant, and cotangent. Cosecant is going to be the reciprocal of sine, which is 5 over 4, or r over y. Secant is the reciprocal of cosine, so that's going to be 5 over 3, or r over x. Let me make that look more like an x there. And cotangent is the reciprocal of tangent, so 3 over 4, or we would say x over y. So now we've found all 6 of our trig ratios for this angle theta that is has a point on its terminal ray of 3, 4. We've also observed that we can think of this in terms of opposite over hypotenuse or adjacent over hypotenuse, but we can also think of it as my y value of my point over the radius of my circle, or my x value of my point over the radius of my circle. So this is part 2, concludes part 2 of your 5-part series on March 23rd's Not Spring Break Day.